All right, you've done the learning. Now let's convert it into interview points. In this episode, I'm going to fire the questions that actually come up in real message broker interviews and give you the crisp version of each answer, the way you'd actually say it out loud. Follow along, pause and answer before I do, and you'll know exactly where you're solid and where you're shaky. Let's run them. Question: why use a message broker at all? Answer: to decouple services in time and space. The producer doesn't need the consumer online, doesn't block on it, and doesn't know who consumes. You gain buffering against spikes, independent scaling, and easy addition of new consumers, at the cost of eventual consistency and harder debugging. Use it when the caller doesn't need the results synchronously. Question: queue versus event stream? A queue delivers a message to one worker and deletes it after acknowledgement. It models task distribution. A log, like Kafka, is append-only and retained regardless of consumption, so any number of independent consumer groups can read at their own pace and replay. Queue 4, exactly one worker does this. Log 4, many readers plus replay plus high volume. Question: at least once versus exactly once, and how do you actually achieve exactly once? At least once means retry until acknowledged, so duplicates are possible, so the consumer must be idempotent. True exactly once at the network level is impossible, the two generals problem. So exactly once really means at least once delivery plus idempotent processing. Kafka's exactly once semantics give it within Kafka. Crossing to an external database needs the outbox pattern or an idempotency key. Question: what is consumer lag, and why does it matter more than error rate? Lag is the latest offset minus the committed offset, how far behind a consumer is. A real-time scorer with high lag acts on unscored events with 0 errors thrown. Green dashboards, broken system. So you alert on the lag trend. Fix it by scaling consumers up to the partition count, then adding partitions, then speeding up processing. Question: how does Kafka guarantee ordering? Only within a partition. You set the key to the entity ID, so all of an entity's events land in the same partition and are processed in order. There's no cross-partition ordering, and the classic pitfall, increasing the partition count, remaps keys and breaks ordering for existing keys. Question: Kafka versus RabbitMQ. RabbitMQ is a smart broker with a dumb consumer. Rich routing, priorities, message expiry, request reply, messages deleted after acknowledgement. Best for task queues and complex routing. Kafka is a dumb broker with a smart consumer. Durable log, replay, huge throughput, many independent consumers, stream processing. Pick by need or use both together. Question: when would you pick the simple queue service over Kafka? When I want a zero-ops managed queue for task distribution on AWS, don't need replay or many independent consumers, and value simplicity. Add the notification service in front for fan out. Kafka only when I need the log model. Question: how does Kafka get such high throughput? Sequential disk writes, which are fast. Zero copy transfer that skips user space. Batching, so it's one network round trip per batch. Partitioning for parallel writes, and compression. Question: what happens when a Kafka broker fails? The controller detects it via a heartbeat timeout and, for each partition that broker was leading, elects a new leader from the in-sync replicas. Clients reconnect to the new leaders. With replication factor 3 and minimum in-sync replicas 2, you lose a broker with 0 data loss.
Question: explain the dual write problem and the outbox pattern.
You can't atomically write to a database and publish to a broker, so a crash in between leaves them inconsistent. The outbox pattern writes the state change and an outbox row in one database transaction. A relay, usually change data capture, publishes the outbox rows. The event is published if and only if the transaction committed. Consumers still dedupe because the relay is at least once. Question: what is change data capture and how does Debezium work? Change data capture streams row-level database changes as events by reading the database's write-ahead log, no application code. Debezium tails the log and publishes every insert, update, and delete to topics. Used for the outbox relay, building read models from an existing database, and data sync. Question: what is the saga pattern? A distributed transaction without two-phase commit. A sequence of local transactions, each emitting an event, with compensating actions to undo completed steps on failure. Choreography for simple flows, orchestration for complex ones. It's eventually consistent, and compensation is a new counteraction, not a rollback. Question: event sourcing and CQRS. What and why? Event sourcing stores every state transition as an immutable event. Current state is the fold of events. It gives audit, temporal queries, and replay to fix. CQRS separates the write model, events, from read models, projections, each tuned per query and built by its own consumer group. Rebuild a projection by resetting its offset and replaying. No migrations. Question: how do you handle a poison message? Classify the error. Retry transient failures with backoff and jitter off the main flow. Send permanent failures straight to a dead letter queue. After some number of retries, dead letter it. Kafka has no native dead letter queue, so you produce it to a dead letter topic and commit past it. And always alert on dead letter queue depth above 0. Question: what causes rebalances and lag spikes? A consumer joining or leaving, a crash, a rolling deploy, or being too slow and exceeding the max poll interval. All consumers pause during a rebalance, which spikes lag. Mitigate with static membership, cooperative rebalancing, and faster processing. Question: how do you design a topic for a high-volume entity stream? Key by entity ID for per-entity ordering. Partitions equal the max of target throughput divided by about 10 megabytes per second, and your peak consumer parallelism, often 12 to 24. Replication factor 3. Minimum in-sync replicas 2. Acknowledgements all. Retention per compliance needs. Tiered storage for long retention. Question: what do you monitor in production? Consumer lag per group and partition first. Then, dead letter queue depth, under-replicated partitions, the active controller count, which should be exactly 1, latency at the 99th percentile, and broker disk usage. Notice the pattern in all of these. Short, confident, structured, lead with the definition, then the mechanism, then the caveat. That rhythm is what makes you sound senior. Next episode, we do it live. Full system design walkthroughs, start to finish.